Hello everyone. In this video we are going to discuss practice exercise 2.1 from second chapter, that is coordinate systems and transformation, from the book that is Elements of Electromagnetics for 7th edition. Okay, so very firstly we are going to write what are the given points, and then we are going to convert that given points which are in the Cartesian system into cylindrical and spherical coordinate system. So let's begin with this numerical. So before that, if you haven't subscribed my channel, please do subscribe that one, and please do hit the like button if you appreciate my efforts. Okay, so let's begin with the numerical. So very firstly, we will start with your point P having coordinates 1, 3 and 5. So we are going to convert this Cartesian system into cylindrical system. For that conversion of Cartesian to cylindrical one, we will need some conversion formulas. So that's what we have. In a cylindrical form, what we have, the given coordinates is expressed in terms of rho, phi and z for your this cylindrical system. Now, what is that conversion? So, if you want to convert that Cartesian coordinates into cylindrical one, so for that purpose, we will have to make use of this. That is, rho is equals to what? Rho is equals to square root of x square plus y square. Then we have the phi. So, phi is nothing but what? Phi is your tan inverse of y divided by x, and z. So, z is as it is for your cylindrical system. Why? Because so if you go through your theory, you have come to know about this is your Cartesian system having coordinates x, y and z. And what about cylindrical one? So cylinder, that cylinder lies around your this z axis, okay, something like this one. So this is your cylinder. Now what that cylinder it will have? That cylinder it will have some radius starting with this z up to some point over here. So that radius is indicated by means of what? Rho. So rho is nothing but what? Radius of your cylinder. Then that radius makes some angle with respect to your this z axis or origin over here. You can say over here. Okay, so that angle made by means of this radius with respect to your z axis to the point onto the cylinder is indicated by means of what? Some angle phi. So that is that angle, some angle phi. So that's what we have. The phi is nothing but what? The angle in between your radius and the point onto the cylinder, and z. So z is as it is. So this is how we are going to convert this Cartesian system into your this cylindrical system. Okay, so we are just simply going to put the values of that x and y's within that formulas, and then we are going to get our answer. Okay, so let's begin with that answer. So very firstly, sorry. Okay, sorry. So very firstly, we are going to start with rho. So what we have for that rho? So rho is nothing but what? We have that rho is equals to square root of x square plus y square. And what is that x and y values over here that we have? So x we have that to be the 1. So x square will be 1 square, and y over here y we have that to be 3. So that will be 3 square. Okay. So answer is what? 1 square is 1, 3 square is 9. So square root of 10. So you will find that rho is equals to square root of 10, and that value I have over here is 3.162. So this is what your very first parameter of cylindrical system, that is rho. Then next is what we have? Next is we have phi. So phi is what? So phi we have that to be tan inverse of y coordinate upon x coordinate. So what is that y coordinate? Over here we have that y coordinate to be 3 and x coordinate to be what? 1. So from this what value we will have for that phi? So phi is what? Tan inverse of 3 by 1, that is tan inverse of 3, and that is equals to 71.56 degrees. So while calculating these values, you just keep in mind you have to keep your cases in the degrees mode so that you will find that r theta, sorry, theta and phi values in terms of degrees. Okay, and then next is we have to find out for the z. So z is as it is, and what is that value? So that value for that z we have to be the phi. Okay, so this is what we have the values of that rho, phi and z. So whatever your point P that was given in terms of that x, y and z as 1, 3 and 5. So if you are going to convert it into cylindrical one, so we have that P is equals to what? 3.162, that is your rho value. Then phi is what we have? 71.56 degrees for your phi, and z is what we have? So z is phi. Okay, so this is what is our final answer for your very first point, that is point P. Now in similar fashion, we are going to get the values of that T and S. Okay, so let's go on to the finding that conversion for your point T. Okay, so we are given with point T having coordinates 0, -4 and 3. So again, we are going to convert that T in terms of that cylindrical one having coordinates in terms of that rho, phi and z. Okay, so earlier we have seen the conversion. So what is that rho? Rho is nothing but square root of your x coordinate square plus y coordinate square. Okay, now square root of x. So what is that x over here? That we have to be 0 square and y coordinate to be -4 square. So what is the value of rho that we will have from this one? So we have that rho is equals to 4. Now next is we have the phi. So what is the phi value? Phi is nothing but what? Tan inverse of your y coordinate upon x coordinate. Phi is what? Tan inverse of y by x. So phi is, what is y over here? We have that y to be what? -4 and x to be what? 0. So here comes the tricky part. So what is the tricky part? So if you are going to put that values onto your calci, you will find that value is coming around to be infinity. Okay, so that is undetermined. You cannot say what exact is the value of that -4 divided by 0. But here in this case, we have the answer to be 270. So this is not the answer. Indeterminate is not answer, but we have that phi to be 270 degrees. So why is that 270 degrees? Why not that undetermined? Actually, that undetermined is also correct, but we have to express it in terms of some angle phi. So why is that one? So if you go through your basic coordinate system, so what is that coordinate system that tells you? So here is what we have the plus x, here is what we have to be plus y, then here we have this value to be in terms of minus x, and here that to be in terms of minus of y. Now if you carefully observe for your given points, what value we have for that y coordinate? We have that y coordinate to be minus of 4, and where that -4 it will lie? So it will lie somewhere around over here. Okay, and x coordinate is what? We have that to be the 0, so that is over here. Okay, so that means in which quadrant your this -4 lies? It lies in your third quadrant, or you can say that lies in the fourth quadrant, because we have the x value to be 0. But if you go for your basic cycle theory of cycle of 360 degrees, so what you are going to write? So here is, it is lying around 0 degrees. Here it is lying around this plus y, it lies around plus of 90 degrees. This minus x, so minus x lies around minus of, sorry, not minus, so that minus x, it is on to 180 degrees, and this minus y, so it is lying around 270 degrees. Okay, So that's why we have this value of phi equals to 270 degrees, because your minus 4 coordinate, so this minus 4 coordinate, it lies onto the minus y axis, having indeterminate value. So since this minus y, it is extending towards minus of infinity, so we can say that phi is at 270 degrees. So this is your final answer, not this one. Okay, so keep this in mind. So well, I hope this concept is clear to you. So if you have these values to be undetermined, having some coordinates value over here, so what will be the value if we have this minus 4 instead of minus 4? What else if it is plus 1? So for that plus 1, whatever you use your phi, so it is coming around 90 degrees. Okay, because why? Because your plus lies over here. Plus 4, it will lie onto the plus of y, having the phi equals to 90 degrees. Okay, so this is the basic difference in between the values of that y and its axis of location. Okay, so keep in mind, now we are going to move on to the next part of the numerical, that we have to find out the z. So z is as it is. So what is that z? So we have that z is equals to 3. Okay, so what is that z? So z will be as it is, sorry, so z will be as it is, and that z is equals to what? That z is equals to 3 over here. Okay, so from this one we have the values of that rho, phi and z for your given coordinate t. So this was your coordinate t, having coordinate 0, minus 4 and 3, and in terms of that cylindrical system we have that t to be 4, then this 270 degrees. So please do practice this one so that you will get the definite answer for that one instead of having that indeterminate. Okay, so this is what we have the coordinates in terms of its cylindrical value. Okay, so this is your final answer for your coordinate t. Now we are going to find out the conversion for your point S, given in terms of minus 3, minus 4 and minus 9. So we are going to convert these coordinates of that S into cylindrical one from its Cartesian values. So earlier we have gone through that conversion. So what we have, again we have that rho is equals to square root of your x square plus y square. So what is that x and y over here? So x and y, uh, that x is what? Minus 3 square. Your y is what? Minus of 4 square. So if you go for its simplification, so you will get that rho is equals to 5. So this is what is your rho for coordinate S. Then next is where to make use of the this formula for finding out the phi. So phi is what? Phi is tan inverse of your y coordinate upon x coordinate. So what is that value? So we will have that phi is equals to tan inverse of minus 4 divided by minus 3. And from this one you will find that phi to be tan inverse of minus 4 by minus 3. So that will be plus 4 by 3, and that is equals to what? Tan inverse of 4 by 3. You will find that value to be 53.13 degrees. Okay. But still the book is saying this is not the final answer. Why is that one? This is not the final answer. Actually, it is also considered to be the final answer, but if you go through the basic theory of your that coordinate system, coordinate. Okay, so just now we have seen for your previous numerical. So what is that one? Again, if you are going to rewrite for your x and y's, plus and minus 1. So what are their locations? So this is what is your plus x, which is located at what? Which is located at either 0 degrees or at 360 degrees. Then next is what we have? Plus y, which is located at what? Obviously it is located at 90 degrees. Then we have the minus x, which is located where? It is at 180 degrees. And then we have minus y over here, which is located at 270 degrees. Okay, so what values we have for that x and y? So we have the x to be minus 3, which will be around some over here. And what is that y? So y is given to be minus of 4, which will be somewhere over here. That is, it is in the which quadrant? It is in the third quadrant. It is in the third quadrant. Okay, so third quadrant is what? Your this total of this 180 degrees plus somewhere over here, which is what? That value we have to be 53.13. So what will be your final phi? So your final phi will be this 180 degrees plus 53.13. So your phi value is equals to what? The phi will be total of 180 plus 53.13. So that is around 233.30 degrees. So this is what is your value for your angle phi. So we just have to make use of the concept of these quadrants and the locations of your point x and y in terms of that plus and minus values at the given respective angles. By using this one, you can get your final correct answer. So this is the point where many students get stuck or they get confused. Why? Because your CAS is going to give you the answer that like 53.13, but the book is not saying that it is the final answer one. So perspective of that given angle is this one. You have to add up this given angle with respect to this location of your x and y coordinates. So here in this case, that total of 180 degrees shifting along with that 53.30 degrees. So that's why we have the final answer phi to be equals to 233.30 degrees. Okay, and then next is what? Next is our z. So z is as it is, and that z value we will have to be what? So we have that z to be the minus 10. So we have the rho, phi and z for your s coordinates, which was earlier expressed in terms of Cartesian, and now we have converted it into cylindrical one. That is, rho is 5, your phi is 233.30 degrees, and then next is z is minus 10, which is as it is. Okay, so this is your final answer. So we are done with the very first part of the numerical, that we have found out. We have converted that Cartesian system, Cartesian coordinates into cylindrical one. Now we are left with this one. So in the next part, we are going to convert this Cartesian system into spherical coordinate system. Okay, so we will move on to that one. So in this part, we are going to discuss the conversion of that Cartesian system to spherical system. So for that conversion, we are going to make use of some formulas. As we know that spherical system is expressed in terms of what? R, theta, and phi. So if you are given with any point P, so in terms of that spherical system, it is expressed having the coordinates or the points that is to be R, theta, and phi. So what is that R value that we have? So we have the formula of that conversion. You can refer the theory for this one. So R is what? R is nothing but what? Your square root of x square plus y square plus z square. So we are going to use this all over here. Then we have the theta. So what is that theta? So theta is nothing but tan inverse of your square root of x square plus y square divided by z. And then next we have the phi. So what is that phi? Phi is as it is. From your previous slide, you can refer that one, or from the cylindrical system coordinate, that is y is tan inverse of y by x. So you just write this formula somewhere over here, and we are going to put that values of that x, y, and z, and we are going to find out what is that r, theta, and phi. Okay, so we will start with that one. So very firstly, we are given with point P having coordinates 1, 3, and 5. So what is the r that we have for this? So we have the r in terms of your Cartesian coordinate system to be square root of x square plus y square plus z square. So if you are going to put the values of that x, y, and z over here, so what we will have? So square root of x square is what? X square is 1 square. Then y square is what? 3 square. And z square is what? 5 square. So from that one, you will find, if you are going to simplify that one, so you will find that r to be what? 5.92. So that is what? Radius of the sphere for your spherical coordinate system. Then next is, we have the theta value. So what is that theta? So that is equals to tan inverse of square root of x square plus y square divided by z. Now you just simply put the values of that x, y, and z over here. So we will have that to be the tan inverse of x is what? 1 square. Y is what? Y we have to be 3 square. That to taken in the square root divided by z. So z is equals to what? Z we have to be 5. Okay, so if you are going to simplify that one, so you will find that theta is equals to somewhere around 32.31 degrees. So that is what is theta. And then next is, we have the phi. So phi is what? Phi is again tan inverse, but that is of y by x. So tan inverse of y. So what is that y? We have the y to be 3 and x to be 1. So if you are going to simplify that one again, you will find that phi is equals to 71.56. Okay, so this is what we have, the Cartesian coordinate of that point P 135, which is converted into spherical one, and that point P is now what? That is what? 5.92, sorry, 5.92 theta. We have that to be the 32.31 degrees, and phi is equals to what? 71.56 degrees. Okay, so this is our answer for conversion of that point P into your spherical system. Okay, sorry for that. Okay, so this is your final answer. Okay, so this is your final answer. Now we will go in a similar fashion for your point T and S. Okay, so for that conversion of point T into spherical one, we are again going to make use of the same formulas, that is R. So we have that R to be what? Square root of x square plus y square plus z square. Now put the values of that x, y, and z over here. So we have the x is equals to 0 square, y is to be minus 4 square, z to be 3 square, And if you are going to simplify that one, you will find the value of that radius of the sphere in terms of spherical coordinate system, and that value r is equals to what? That is equals to 5. Then next is we have the theta value. And what is that theta? So that theta is what? Tan inverse of square root of x square plus y square divided by z. So put the values of that x, y and z within this equation. So x is we have to be 0 square, y is equals to what? Minus of 4 square, and z is as it is, that is 3. So if you simplify this equation, you will find that theta is equals to 53.13 degrees. Okay, and then next is we have the phi. So phi is equals to what? Tan inverse of y by x. So put the values of that y and x. Y is what we have? Minus 4 and x is 0. So earlier we have discussed what is this answer. So initially it comes out to be minus of infinity for your phi, but from the perspective of that coordinate system and the location of that x and y's, so we have that phi to be 270 degrees. You can refer earlier part of the same video in order to have the deep understanding of that one. Okay, so I am not going to discuss that part over here. Again, you can pause this video and revert it back so that you will get your answer. The next is your point S. So point S is what? Minus 3, minus 4 and minus 10. Uh, okay, let me rewrite it for you. So that T in terms of your that spherical system is what? 5, 53.13 degrees, and then this phi to be 270 degrees. Okay. So again, you just put the values of that r, theta and phi and get the values of that s. So meantime, I am going to rewrite it for you. You just have the calculation. I am going to pause this video and directly writing it for you. Okay, so for this S part, I have written for the value of that R, and I have also written up to that value of theta. But if you look out for this theta value, so what is that theta? That is tan inverse of root of x square plus y square divided by z. And if you are going to put that values and if you are going to simplify that one, you will find that theta is equals to around minus of 26.56 degrees. Okay, so this answer is not acceptable because again we are going to make use of that system of coordinates. So what values we have? We have the root of x square plus y square, that is also in terms of minus values, and this z is also in terms of that minus value. Okay, so earlier we have gone through this again and again. I'm repeating it for your understanding purpose because this is the crucial part. If you forget about this one, you will find even though you will have the answer to be correct one as per your calci, but still that answer is not acceptable. So that's why I'm focusing on to I'm stressing on to that one. So whatever this your that root of x square plus y square, that is again minus value, and this z is again minus value. So for that purpose, we are going to add up this it with respect to your 180 degrees, and we are going to rewrite that theta is equals to what? So you will have that theta is equals to 153.43 degrees. Since both values are negative, So that negative values lies in what? In your third quadrant. So this is your 0 degrees, this is 90 degrees, this is 180 degree, and this 180 degree plus your this angle. So this angle is what? Minus 26.56. So that's why we have the theta is equals to 153.43 degrees. And then next is we have the phi. So phi is equals to what? Tan inverse of, sorry, sorry for that one. So phi is equals to tan inverse of y by x. Now put the values of that y and x over here. So that is equals to minus 4 divided by minus of 3, and you will find that to be the 53.30 degrees. But again, we are going to add up plus 180 degrees over here. You can refer my previous, sorry, not previous lectures. You can refer same video for that why this 180 degrees is over here, and if you have gone through that one, you will come to know about that one. So that phi is coming around to be what? 233.30 degrees. Okay, so even though the video seems to be lengthy, it is worth to watch this one because I have gone through the detailed concept within this numerical. Okay, so this is what is your final answer. Let me rewrite it for you. So S in terms of spherical system is what? 11.18. Then theta is 153.13 degrees, and phi is what? We have to be 233.13 degrees. Okay. So I have broken this exercise 2.1 in terms of in parts of A, B, and C. So this is the A part of the practice exercise 2.1. So in the next video, I'm going to discuss about part B, and in the next to next video, we are going to discuss about the part number C. So if you have any doubts, please do comment. If you appreciate my efforts, please do hit the like button, and please do comment so that I can get the feedback whether you're understanding the concepts or not. Okay, thank you.